This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video, we're going to be looking at applications of the formulae found in the Formulae and Tables book for trigonometry. So our first example asks us to express in third form sine of 105 degrees. And we're asked to use the special angles. Now the special angles are the ones that you can find in the tables, angles such as 30 degrees, 45 degrees, 60 degrees, and 90 degrees are all special angles. So the easiest way to do this question is to split up this 105 degrees into a sum of two of these special angles up here. So the way we can do that is to realize that 105 is the same as 60 plus 45. And then once we have that, we can use the sine of a sum formulae found in the tables, this equation here, and we can just sub in our values for A and B. So in our case here, we have that A is 60, B is 45. So if we fill these values into our formula, we end up with this equation, and then each of these values, for example, the sine 60 here, can be worked out using the tables. So sine of 60 is root 3 over 2, and so on. So cosine of 45 is 1 over root 2, and likewise sine of 45 is 1 over root 2, and cosine of 60 is a half. Then we just multiply these expressions to end up with root 3 over 2 root 2 plus 1 over 2 root 2. And since these two parts have the same denominator, we can just add the top together to get our final answer of root 3 plus 1 all over 2 root 2. Our next example reads, if tan of A plus B equals 4 and tan of B equals 3, we need to find tan of A. So our solution in this case is going to be to look at the formula for tan of A plus B, and that's given in the tables as tan of A plus tan of B all over 1 minus tan A times tan B. So that formula there. We know from the question that tan of A plus B is equal to 4, so the left-hand side is just 4, and we fill in our various values the values given in the question, where we have tan A as our unknown, and we know tan B is 3. Now I'm going to use a substitution here where instead of writing tan A all the time, I'm just going to write T, just to simplify the next couple of lines. So instead of writing this line here, I'm going to instead write that 4 is equal to T plus 3 all over 1 minus 3 times T. Then if I multiply this equation, both sides, by 1 minus 3t, like so, we see that the 1 minus 3t cancels on our right hand side, leaving us with this equation over here. 4 minus 12t is equal to t plus 3. Once we multiply out this left-hand side, and we're just left with a t plus 3 over here. Now we reorder this equation to get everything that involves t on the left and everything that doesn't involve t on the right. So we subtract t from both sides, and we subtract 4 from both sides, leaving us with minus 13t on the left, and minus 1 on the right, meaning that t is 1 divided by 13, and I said before that we had tan of a is t, so just replacing t with tan a, we get our tan a is 1 over 13.